This is a brief presentation on a runway incursion prevention technology dubbed Simple, Affordable, Flexible, and Expandable Runway Status Lights, or SAFE-RWSL. SAFE-RWSLs tackle the risk of runway incursion at all airports while being cost-effective and applicable to smaller towered and non-towered airports as well. Runway incursion prevention technologies are only available to the busiest of airports. Additionally, current efforts by the FAA are focused on towered airports. Yet when looking at accidents from 2010 to 2020, all 23 runway collision accidents in the United States occurred at non-towered airports involving general aviation aircraft. Part of the problem identified with existing solutions is that most runway incursion prevention technologies are impractical. Through a review of existing solutions and previous proposals, it has been found that restrictive costs, the lack of buy-in from additional stakeholders, and the overall complexity of implementation were barriers to the introduction and implementation of many solutions. Hence, SAFE-RWSLs were proposed and developed as a solution for runway incursion mitigation. Inspired by crossing signals, a simplified runway status light system promises to provide an extra layer of safety applicable to all airports. Taking inspiration from railroad and pedestrian crossing signals, SAFE-RWSLs work by providing stop indications at runway entrances. Based on current stop bar implementations, the current SAFE-RWSL design uses stop signals co-located with runway guard lights to provide runway status indications. The system works by having surveillance modules detect aircraft and wirelessly broadcast runway status information to runway status lights located around the airport. ADS-B in conjunction with computer vision modules are used to detect traffic. Computer vision modules strategically placed around the airport detect aircraft using approach surfaces, while additional computer vision modules cover the runway surface to detect aircraft, vehicles, and pedestrians. An ADS-B receiver is then used as a secondary system to detect relevant aircraft and vehicles equipped with ADS-B transmitters. The ADS-B system detects traffic by using a geofence and other filtering methods to determine relevant traffic, while the computer vision system, covering the same relevant surfaces, functions by having visual line of sight of relevant traffic. A prototype system was built and is being tested using runway 523 at the Purdue University Airport. The modules of the system are plug and play, really drop and play, being completely self-contained, requiring no additional wire and functioning wirelessly with each other. The system works. As you are about to see in this video of the light mockup, configured for the hypothetical operation at the runway entrance seen in the video, which is located at the beginning of the runway with a displaced threshold, a stop signal is indicated when an aircraft is approximately 30 seconds away from landing. Within the control box, you can also observe two different red lights that come on. The top light indicates the detection status from the computer vision system, while the bottom light indicates the detection status from the ADS-B system. Now in a few seconds, as the aircraft crosses the runway threshold, you'll notice that the stop indication will extinguish. The computer vision algorithm successfully detects landing aircraft by identifying aircraft using an object detection model, and then determining whether it is relevant or not using an additional algorithm. As you will see through these examples, the system can detect and see aircraft quite far out and successfully identify a landing sequence. Additionally, while birds can confuse the object detection model, the algorithm built on top of that system is able to successfully filter this out and successfully detect landing aircraft regardless. In a randomly sampled test set of 110 landings, The computer vision system was able to successfully detect all 110 landings with no false positives. The SAFE-RWSL system won first place for the runway safety category of the 2021 to 2022 Airport Cooperative Research Program University Design Competition and was subsequently awarded as part of a 2023 to 2024 ACRP Graduate Research Award. The approximate cost of the built prototype is $5,000. Compare that to the approximate cost of ASDEX, the surveillance system current runway status lights operate on, which cost approximately $30 million. The SAFE-RWSL system, powered by its computer vision surveillance system, will also be able to detect non-cooperative vehicles and pedestrians, and can be modified to count aircraft operations, detect relevant wildlife, and possibly detect foreign object debris, all while operating under one system. Purdue University's Office of Technology Commercialization is currently working on a non-provisional patent application for the system and is looking for interested companies to license this technology. Further testing and human factors evaluations are now being carried out to further determine its reliability and effectiveness in a variety of situations. Thank you for your interest in this project.